Gordy, what's the first thing I want to do here on example number 3? Looking at A, that is.
You want to divide both sides. Wait, you want to distribute.
All right, Gordy's telling me that I want to simplify first, so I need to distribute. Good, Gordy. So I'm going to do 7 times A. That gives me 7A. 7 times negative 2 gives me negative 14 minus 6 is equal to 2A plus 8 plus A. Whenever I'm simplifying, the very first thing I'm going to do is distribute. Okay, what's the second thing that I do here, Troy? Add like terms or combine. So in this, on the left side, I've got negative 4 and negative 6. That can give me 7A minus 20 is equal to, and then on the right side, I've got 2A and A. So that's going to be 3A plus 8. Okay, now I've distributed. I've simplified by combining also. Now I'm ready to get these variables together. Okay, CB, what would you do first here?
I would add 20.
CB says he's going to add 20 because he's not listening to me on my last example. What's the very first thing we want to do, CB?
You're going to want to subtract 7A.
Yep, well, yeah, I can subtract 7A. That's fine. I just want to cancel one of the variables out so that I only have it on one side. Okay, so the 7A and the minus 7A, those cancel and leave me with negative 20 is equal to negative 4A plus 8. Okay, now Hugh, what do I want to do from there?
You want to subtract 8.
Hugh says let's go ahead now and subtract 8, not 7, Mr. C. All right, and those are going to cancel and leave me with negative 4A is equal to negative 28. All right, I like that. Austin, where do you go from there? Divide by 4, divide by negative 4. Here, let me change the color. Divide by negative 4 on both sides, and I'm going to get positive 7 is equal to A, which is the same by the reflexive property as A equals 7. Okay? Or not reflexive, but symmetric. Right? I can just flip that around. 7 equals A, then A must equal 7. All right? Okay. Let's go back up. I'm sorry, I almost skipped B here. Okay, what's the first thing that I want to do here, Miles? Miles says I need to simplify, and the very first thing I need to do to simplify is distribute. Good job, Miles. I'm going to distribute that 3 times 1 and get 3. 3 times minus r and get negative 3r. And I'm just going to drop down the 5r is equal to 2 times r, which is 2r, and 2 times 1, which is 2. Okay, so now I've distributed. What's the next thing that I need to do in simplifying, Gordy? Combine like terms. So I'm going to look on this left side, and I've got negative 3r and positive 5r. So that's going to give me 3 plus 2r is equal to 2r plus 2. This is going to be interesting. Devin, what do we do next? What do you want to do?
Subtract 2R.
Yeah, definitely I want to get the variables together, right? I want to cancel one out. So I'm going to subtract 2r from both sides. And then I'm going to get, wait, let's see, this cancels with that and leaves me with 3. This cancels with that and leaves me with 2. That's interesting. That's interesting. I don't have any variables left now. And I have that 3 equals 2. What does that mean? Because I know, I've been in math long enough to know that 3 actually does not equal 2. Right? What's that mean, Gordy?
It's not a true statement.
It's not a true statement. That's definitely true, what you've said. But what can I deduce? How would I write an answer here, Benny? No solutions. And what that means is just that there are no values of r that when I plug it in will give me a true statement. Okay? There are no solutions that make this a true statement. That happens. Okay? Look, we got, and here's a way that we can see it. It says 3 plus 2r equals 2r plus 2. Well, whatever 2r is, it's the same on both sides. I can't add 3 to a number and have it be the same as when I add 2 to it. Right? 2r plus 3 can equal 2r plus 2. Okay, so I can see right there are no solutions. But if I didn't see it, and I didn't until I got to the end, 3 doesn't equal 2. That means no solutions. One quick thing, guys, in the last 15 seconds before my timer runs out. What if it had said 5 equals 5 or 0 equals 0? What does that mean, Troy? There, not just a variable, but infinite solutions. Good job, guys. See you at example